Hi guys, in this video we're going to put everything together we know about hypothesis testing, and we are going to take a look and see how we actually do this. Okay, so remember we have 5 steps to hypothesis tests, and again this is for means and proportions in sections 10.1, 10.2, and 10.4, and those guided notes can again be found on the Canvas website. Okay, so let's just take a look at the steps here. This is a hypothesis test that we fully worked out, and what I want to draw emphasis to are the steps. So remember, step 1 was to state the hypotheses. Step 2 was to compute our test statistic, which is a fancy name for the z-score. Step 3 was the p-value. Okay, we get that from our normal distribution table, so hopefully you've got that handy. And step 4 is to compare that p-value to the level of alpha. Alpha is that level of significance. And then step 5 is to state the conclusion, where we actually answer the question. Okay, so let's take a look and see how this works out. So it says, skeptics believe that coffee drinkers cannot tell the difference between fresh brewed coffee and instant coffee. We think it's more. We perform an experiment where 50 subjects taste 2 unmarked cups and choose which tastes better. Of the 50 subjects, 29 choose fresh brewed, and we will perform a hypothesis test to see if more people prefer fresh brewed coffee over instant brewed coffee. Okay, so a couple things to notice here. The first is that they don't talk about means anywhere, right? So this is going to be dealing with proportions. So that's why we're using P in the hypotheses. And remember, the hypotheses are always statements made about the parameters. And so in this case, we've only got 2 choices, P and mu, and so we have to use P. Now in this case, it's a little hard to understand why we're using 0.5, right? It doesn't mention 0.5 anywhere in here, but you got to think about this. So we've got 2 different cups of coffee, right? We've got this fresh brewed and instant coffee. And so if 50% of people can tell the difference for each, then there's not much of a change, right? 50% and 50% is even. There's no majority anywhere. And so that's why in the alternative hypothesis, we take P to be greater than 0.5. This means more people can tell the difference. And so that 50%, getting that 0.5 is sometimes a little bit tricky for people to see, at least in the context of this example. And so that's why we're treating it in that way. Now, to get the test statistic, what I want to make sure that we really understand here is that we have a test statistic that we have been given. So it says we know that p hat is 0.58. Now everybody says, where did we get 0.58? Well, p hat in this case is given to us as 29 over 50. Okay, do you guys see how it's saying that in here? Of the 50 subjects, 29 choose the fresh brewed. So because that's coming from a sample, we have to use p hat. Okay, and so that's how we're getting this to be the 0.58. And that's important because it's this sample that we want to determine is really occurring by chance, or is there something else kind of going on there. And you'll notice that when we compute that test statistic, we're taking the probability that we get p hat more than 0.58. Now what I want to really draw emphasis to, does everybody see the inequality here? That inequality greater than is the same as the alternative hypothesis. So there is a direct link there between the two. So if the alternative was less than, then this probability here would also be less than, okay? But instead it is greater than. It always follows what the alternative hypothesis is. Now if you're wondering what happens in a two-tailed test, we'll look at that, I promise, in one of the examples. Okay, now when we write it out as p, probability of p hat being greater than 0.58, guys, this is chapter 7. Okay, so now you proceed exactly as you would in chapter 7. And so you have to remember that fancy formula, okay, to compute the z-score. Remember, it was p hat minus p over the square root of p times 1 minus p all over n. Hopefully you all remember that. Now, we can use p because you know it, right? Where is p? P is right up here in the null hypothesis, right? And the alternative. And so you should notice it's right here, okay, as we marker here. There we go. Right, there it is. And so this work here where it says S, that's the denominator. So sometimes we tend to write that computation out a little separately. And so 0707 is simply your denominator there, okay? So we've got 0.58, which again is p hat, minus 0.5, which is the parameter, again coming right from the hypotheses, divided by 0.0707. This gives us a z-score of 1.13. Now I want to pause here because this is 1.13. This is your test statistic. Okay, so somebody asked you on the test, what's the value of the test statistic? It means you got to get the z-score. There it is, 1.13. Okay, so that's the computation for the test statistic. Now the next part is we have to get the p-value. Okay, so to do this, we have to go to the normal distribution table, and you can see that I highlighted that previously, but I'll circle it again for you. So if you have that normal distribution table ready, what you have to ask yourself then is, what is the z greater than 1.13? This is area to the, and hopefully you guys are filling in the blank, area to the right. Okay, and so you've got two ways to look at that. You can actually go and look up negative 1.13, okay, on your z-score table, or you can certainly just look up the value for 1.13, which is area left, and then subtract, and that's what I've done here by taking 1 minus. Either way, you should get 0.1357. Okay, that's known as the p-value. Now, again, p-value means probability, if you remember back in the definitions, and that should make sense because the normal distribution table shows us, remember, area under the curve, probabilities, and percentiles. All of that is synonymous, all means the same thing. Now the next thing we have to do, step 4, is we have to compare that p-value to the level of significance. And so what I usually do is I usually write it like this. I'll say p-value versus the level of alpha. And in our case, the p-value we computed was 0.1357, and the typical value of alpha we get is 0.05. And so the question is, okay, well, which one's bigger? Okay, and it's very clear that 0.1357 is much larger than the level of alpha. Okay, so remember, in order to be significant, we have to be less than alpha. In this case, it's greater. So that's why the decision is to fail to reject the null. So again, we need that p-value to be less than alpha. That means that we have a case that's very rare to have been occurring. This one is not. It's much larger. Now in step 5, it says that we have to state a conclusion. So the conclusion is to actually answer the question. So let me move the screen up here because I got to remember what the question was. And so it's really the last line, right? It says, we will perform a hypothesis test to see if more people prefer fresh brewed coffee over instant brewed coffee. Well, since the results indicated that it was failing to reject the null, then what we say is that we cannot say that more people prefer fresh brewed coffee over instant brewed coffee. And so that conclusion literally answers the question. And then finally, there's a note, okay, very important. And what it says is this does not prove the hypothesis is correct. We just did not find a sample that gave us statistic to disprove the null hypothesis. So that is a full test all the way through. And what I'll do in the next video is run through a hypothesis test with proportions, and then we'll do another one with means. But I do want to draw out what is listed in the guided notes. I would encourage you very much to read this last section, which pretty much talks about a lot of the stuff that we have been looking at here.